All right, the following is an experimental design based on intermolecular forces and how it relates to viscosity. So what I've done is kind of taken my own spin on the Great Ketchup Race, which is one that I have done using Flynn Scientific in the past. So what I would have students do is using just any type of baking sheet. The first thing I'd want to do is label a start and a finish line for the students. I would have them collect different household liquids that they have so that they can test the viscosities. And then what we would do is kind of start to set up the experiment. The first part of this then would be to add about 1 tablespoon, a half to 1 tablespoon of each liquid. And then the first thing I would do is have students make some general observations. I think there's a lot that you can tell in terms of the strength of intermolecular force and how much the liquid either stays together or spread out. So you can tell with the ketchup that's pretty much held its shape that it has higher intermolecular forces versus the honey or even the olive oil, which I didn't even put on there because I knew in terms of intermolecular forces it was going to spread quite a bit before we started our experiment here. So that'd be the first thing I would do is have them kind of make some inferences. From there, they could make some predictions based on what they're seeing in terms of their ability to hold their structure, which ones have high intermolecular forces, which ones have low intermolecular forces, and how that's going to affect their viscosity. All right, so viscosity, the resistance of a liquid to flow. So in the race, you actually don't want to be the winner. The winner then obviously would have the lowest intermolecular force and the lowest viscosity. So you could run this 2 ways. You could do the experiment first and have them write their observations and then go back and provide a reasoning for them, an explanation for the observations that they see. Or what you could do, in the way I would like to do it, is have them make predictions first. Have them look at the structural formulas for the different substances that are provided and then go ahead and make predictions. This one has higher intermolecular forces, this one has lower intermolecular forces. This should have a higher viscosity versus lower viscosity. All right, so what you would do then, obviously, is you would go ahead and start your experiment. So for ours, we have ketchup, honey, olive oil, Karo syrup, and chocolate sauce were the liquids that I decided to use. Again, I'm gonna try to do this without spilling. I'm gonna add the olive oil just a little bit here. And again, you'd be able to see from the spread how that affects the intermolecular force. And then what I would do is on the count of 3, they would just need to lift up and the race begins. So right away you can see in terms of intermolecular forces, olive oil having the lowest intermolecular force goes quickly, all right? So a very low viscosity goes all the way to the end. It looks like next up we've got kind of a race between our corn syrup and our chocolate, with the corn syrup taking the lead, and then our honey, and then coming in at a very slow pace is our ketchup, which has a very high viscosity. So if you look up the viscosity of ketchup, it's like 50,000 CPs versus some of the lower CPs that you would see for some of the other liquids. All right, so they could run this until obviously the liquids got all the way down to the bottom, but you're starting to get a feel for the level of viscosity through each one, through this real kind of simple at-home experiment that they could do based on viscosity. All right, so the big viscosity race. A couple things that I like about this activity is there are some extensions that you could do. If there are other variables, you could set this one up as a class, but maybe as an extension, test different variables. In terms of ketchups, maybe you could get, name brand versus store brand generic ketchup and see which one has the higher viscosity based on maybe its water content. Does the Heinz ketchup really have the highest viscosity? Another option would be to take something like the Karo syrup and play with temperature. What happens when you decrease the temperature? What happens when you increase the temperature? How does that affect intermolecular force? How does that affect the viscosity? And the third extension that I think would be very interesting could be the change up of the baking sheet. Maybe instead of a baking sheet, which might be adding some frictional force, maybe you would use glass or wood and see how whatever surface substance that you have the viscosity going on, that frictional force, how that affects viscosity as well. So again, just a nice, quick little easy experiment to look at the relationship, that direct nature between intermolecular forces and viscosity.